Welcome back. We have flip-flop 6, which is on constructing a D flip-flop. We're going to do it in two different ways. You should see a similarity between this circuit and in the previous one with the clocked RS. The only difference actually being is that we've tied the R and the S together and we put an inverter between them. And in fact, what we've actually done is we've eliminated the hold state and the prohibited state. So we only have a set and a reset. So if it's 0 here, it's going to be 1 here and vice versa. The other thing to note here is that when this clock is 0, when it's inactive, what happens? Well, anytime we have a 0 going into an AND gate, it's going to result in a 1. And that creates problems for this gate or this circuit because it will not allow this data, whatever is here at D, to be stored in the flip-flop unless this is activated and turns to 1. So it kind of turns the whole entire flip-flop circuit off if this is at a 0, which really should explain things for you about why that clock pulse is so important in storing that data. So I want you to construct this circuit using a couple of LEDs, again green for your Q, red for your Q naught, and test the truth table from what you had in your previous whisking from the flip-flop 5 video. Okay, the second thing you're going to do is build a commercial D flip-flop. So you're going to need a 7474 chip to do that. Okay, and you're going to need to wire it up. And the same thing, you're going to have two LEDs, one for the green on Q, one for the red on Q naught. And then you're going to have to wire this preset and clear as well. And you're going to have to test each mode. So the first part you want to maybe test, I would test, is maybe put both set and reset to 1. So put them to positive. And then check to see that it works in the synchronous mode with your clock, with your 555 timer. And then next I would just try to test this asynchronous set and asynchronous reset to be sure that they both work, and also try the prohibited state. Now the chip that you're going to be using, here is the chip that you're going to be using, the 7474. You can see it has two different flip-flops, okay, on one chip. And pin 14 goes to positive, pin 7 goes to ground. Okay, you've seen that before. And you can see how the bottom half here controls this one flip-flop, the top half controls the second flip-flop. So I'm sure you can figure out how to wire that together. So ask your instructor for one of those flip-flop chips and build both circuits, one with NAND gates and one with the IC.